for geospatial analysis organized by IPHA. It will be a 5 days session, and hopefully it will be a good hands-on and interactive session. We have with us, for us, very well known and very respected sir, Dr. Arijit Morzumdar sir. He is from Jadavpur University, from Department of Geography, assistant professor. Sir is interested in many works. Sir is famous for his many works, and especially his works in geomorphology, climatology, hydrology, statistics, remote sensing and GIS, watershed management. His work in interests are more work research interests in groundwater hydrology and water resource management. He has multiple publications, national publication, international publication in high-end journals like Springer and others. I am fortunate for getting a live class, offline class of Sir previously, and it was an wonderful experience that how a person can teach GIS so easily. He made us easy for everyone on that class. So I have experience of Sir's teaching. I hope it will be great. You will all enjoy. So we will let's start our session. I will request Sir to start with the with our topic. Sir.
Okay, thank you. Am I audible?
Yes, sir. Yes.
Okay, thank you. Thank you, Dr. Arnab Sarkar. It's a privilege for me, being a geographer, interacting with so many doctors already. There are 70% almost signing into the Zoom meeting. So I am fortunate enough getting a chance of discussing whatever we learn in our research and our academics. So directly going into the point, I know what I expect is that, first of all, yesterday night I wrote that kindly download QGIS 3.14, workstation, laptop, computer, PC, whatever maybe. After that, somebody wrote that whether they can download 3.34. So first of all, if it is being downloaded, then it's fine. If it is not, then during the session you can just download it. Going into the fact, but I would also like to introduce two of my dear students or scholar, whatever I say, research scholar, Mainul Islam and Shomen Ghosh. Both of them will be assisting me during the session because there are a lot of people. I hope that we can give you some adequate data, material, and knowledge. Maybe just discussed both from the both ends, so that it's understandable and it's workable, or it's rather executable for you. Not going into the details of the geometry or the configurations of the art, but still I will say a few things regarding the art shape and size. Otherwise, when we will be performing our steps, it might feel very confusing that why I am choosing this and why I'm not choosing the other thing. So for example, if we say that we are working in a platform where the operating system is Windows and we are working in a GIS platform. So mostly what happens in a Windows or say in a GIS platform, there are a lot of options given. Now we choose from that and we select it, and then we go for execution of those things. But it's also important in any software environment, what I personally feel is that what we're choosing is all right, but what we are not choosing, there should be some certain reasons that is the reason why I'm not selecting that particular event maybe. So for that, I'll be showing you a few slides regarding theory, and then we'll be straight away going into the practicals of it. I have shared the program schedule. Before going directly into the theories, the first thing I would like to say that I know everybody knows that, but it will be I propose that it is my work to say all these things. Maybe a repetition of the knowledge to you, but still I will repeat these things. Neither I am a software engineer, nor are you. You are doctors, and I'm a geographer. But still, whatever I have learned, I'm just repeating the steps, repeating some few knowledge that you already have. First of all, softwares are of two kind. Basically, one is the operating system, another are the apps. Say, for example, Windows operating system, Android is an operating system. Whereas the apps or the applications we daily handle in our phone, in our mobile, in our laptop, in our desktop, say, for example, Excel must be an application, Word must be an application, Notepad must be an application. Similarly, QGIS is also an application. So these applications are being installed in a platform which is known as the operating system. Whenever you are going to download QGIS, or I hope that you have downloaded QGIS. So when you download it, you find two important things. One is donate. That knowledge, donate is in terms of knowledge. And another thing is what kind of platform do you want to install this particular software? So these are the applications which we basically install in our operating system. So here is a classification of software. Again, on the basis of its price and marketing policies, again, the softwares are being classified into three things, into three ways, in fact, I can say. Number one is the proprietary softwares. Say, for example, basically, I and my scholars in this particular lab work in an environment which is known as ArcGIS or ADAS. ArcGIS is a software which is very robust in nature, so is ADAS. We do all the things in remote sensing and GIS in ArcGIS and ADAS, mostly. But the problem is that they cost heavily. One license of ArcGIS is around 12 lakhs. One license of ADAS is around 7 to 8 lakhs. So they cost heavily. So these are the softwares which are basically the proprietary softwares. Next is another kind of software, basically application software. So the first one is the purchased one. So second one is you get it free, but still they are proprietary. That is, when the proprietor of that particular software wants to update that, he can update it. Once he wants to change anything in that, he can change it. But general public cannot do it. Okay. Say, for example, you want to open a PDF file in your phone, in your mobile, or in your laptop. So mostly we use something called Adobe Acrobat or some supports of PDF. Now, generally, we don't purchase it. We get it free. You can download it, you can install it, and you can use it. So you can say that these softwares are rather free, being provided by the proprietors. Actually not free, but still, if we consider on our aspects, we don't pay anything for that. So you get it and you can use it. So this is another kind of software. So the first one you can say as a purchased one. Second one we can say as software that we get free. We get free, actually not free. The third one is known as the open source software. So what is basically an open source software? Open source software is something which is generally not proprietary. The previous two were proprietary. Here, say for example, we develop a platform, say me and my scholars develop a platform for doing a particular thing. And then we just upload it in the internet. And we do something that like WebGIS or something. It's actually not WebGIS, but we give it in such a way that people in the world, in the whole world, can use it. Now, somebody is using it, say, for example, in Australia or US, and says that, well, these things may be updated and these things may be changed. And I have got that particular knowledge and I want to donate. So he or she can donate into that. And once the admin accepts it, that software gets updated. But here, nobody is a proprietor for that particular software. So QGIS is a kind of software which we call as an open source software. or it's absolutely free and open source, because everybody donates knowledge to that. Everybody can donate knowledge to that. It depends on the admin to accept and update it. Therefore, these softwares go on updating very fast rather than the proprietary softwares. So we all will be working in this particular environment, which is known as Quantum GIS or QGIS. So this is the fundamental of the QGIS. Now, just going into the geometry of the Earth before going into the things. Just what do we basically do in a say software environment? We do a lot of spatial analysis, generating rasters and vectors. But whatever kind of raster analysis we do, or whatever kind of vector analysis we do, the most important problem is that I cannot see anybody over here. And I actually don't know that whether I'm starting from the correct point. If somebody or anybody is there, without, it may happen that without any knowledge of GIS, please interrupt me so that I can understand that what should be the matter of interaction for the first day at least. Okay. So the first thing which is important, that is whatever say for example, if I say maps. Okay, so maps are basically two-dimensional representation of the three-dimensional surface of the Earth. But again, the fact is the Earth is not a very perfect sphere, and it's not very geometric itself. So we need to understand that there are three dimensions at least. I mean, say for example, I'm sitting in this particular room, and I want to locate anything. Say the tip of this pen. I want to look at the tip of this pen. So what I need is that I need at least three dimensions: X, Y, and Z. So everybody of you are sitting in a room, and if you can consider the corner of that particular room to be as an origin 0, 0, 0. So one axis can be determined as x-axis, the other axis can be determined as y-axis, and the third axis may be determined as the z-axis. So if you can locate this particular coordinate, then we can move on for the mapping. So we often book an Uber, say for example. We give orders to Zomato and Swiggy, and they come to the location very easily. But normally what we find in our apps is that we give the latitudes and the longitudes very easily, but there is another dimension which is known as the third dimension. Say, for example, this maze is actually the surface of our Earth. And so there are three levels. So one is the x-axis, next is the y-axis, and the third one is the z-axis. So if we can locate these three axes properly, so every point will be having three coordinates, or a coordinate, in fact, you can say, which will be giving this kind of mess or the interaction on the surface of the Earth. So what are the dimensions? Let me just, if we just see. So the first dimension is the latitude, the second dimension is the longitude, and the third dimension is the data. So what is data? I'm coming to that, because I'm telling all these things because as we move up into the software environment, you'll be getting these terms. Okay. So had the Earth being a very perfect sphere, so these are how the coordinates are located. So a latitude is angular distance from the equator. Say here is a point. Say for example, here is a point, and we want to know that what is the latitudinal value of that particular point. So what is that? If this is the equator, we know that this is the equator of the Earth, and this is the center of the Earth, say for example. So the angular distance, that is the angle it makes with the equator, that is the latitude. And mostly we sometimes say that latitudes are the parallel lines to the equator, but actually not. The unit of latitude is degrees. Again, the unit of longitudes is again in degrees. So these are not any lines, okay? These are actually angles. So this is the latitude, how a latitude is being determined. This is again from the prime meridian. The deviation of the angle gives you the longitude. Say, for example, if
Sorry to interrupt you.
yes, ma'am.
Are you showing some presentation because we are unable to see it?
Yeah, I am.
No,
Oh,
sir, we don't. We are unable to see it. Many of the participants have the same views.
just a minute, just a minute. I've shared it. Can you see it right now?
Yes, sir, visible. Thank you so much.
Oh, sorry, I missed out it. Very sorry. So this was the maze actually I was showing that this is the maze, that is the x-axis, y-axis, and the z-axis. That is how we look at this. Is it visible right now?
Yes, sir, visible.
Okay. So this is the maze, that how we create the surface of the earth, how we create the maps for this. The next one is, as I said, that whenever we are doing with this, the dimensions are latitude, longitude, and the data. I'll be going to the data, in fact. So this is how the latitudes and longitudes are being marked. Okay. So the latitude, as I said, that it is an angular distance from the equator. So say, for example, this is the equator. So this should be the angular distance. And this is the longitude. Again, it's angular distance from the prime meridian. This is the shape of the earth. The shape of the earth is almost like this. We all have read in our, maybe class 6 or 7, that geoid. Geoid, we say that it's something which is known as the shape of the earth. But actually, very technically defining, geoid is the equipotential surface with respect to gravity. That means from the center of the earth, wherever the potentiality of this gravity equalizes, and if we join the locus of those points, that is actually geoid. So since you can see that this geoid actually deviates from a perfect sphere. So for example, if I look at the previous image, now this image is a particular sphere, it's a perfect sphere. Now mapping over this particular thing, mapping this particular spherical or the 3D surface into a 2D surface would have been much easier as compared to this one, because there is a huge deviation from a particular sphere, and that is what is known as the shape of the earth, that is geoid. Gravitational force. Okay, I'm leaving this slide. I'm also leaving this slide. Okay, so let's say I'm telling you a fact that how this world is being actually mapped and how we will be mapping it. Say India, George Everest and his team surveyed India right from Kashmir to Kanyakumari, right from Kashmir to Kanyakumari. And while surveying, they got us an arc-like thing like this. Say for India extends from 8-degree north to almost 30-degree north. So 8-degree north to 32-degree north, that means almost 24 degrees they have surveyed, 24 degrees. So while surveying, they got an arc like this, okay? They got an arc like this. Now, it is not possible for any team to survey the whole world. Now, this survey took almost 40 years. This particular survey, surveying India right from Kanyakumari to, right from Kashmir to Kanyakumari. So they got an arc like this. So once they derived or generate an arc like this, what happened is that they took 2 points, two tangents. In fact, here is a tangent. They draw a tangent over here, and they draw another tangent over here. Or you may draw a number of tangents over here. So once you draw a tangent and you draw a perpendicular bisector of that particular tangent, just you draw a tangent. I think everybody knows what a tangent is. It touches just a point on the surface of the arc. So this is a tangent, again this is a tangent, and then you draw a perpendicular bisector on that particular tangent. So once you draw it, once the perpendicular bisector meets in a particular point, so the distance from here to here will give you the radius of that particular arc. So once you get the radius of that particular arc, you can just draw a whole circle, and this whole circle will actually represent the earth surface. This whole circle will actually represent the earth surface, and this is known as datum. Okay, this is known as datum. That is the third dimension. So the first dimension was latitude, which is the angular distance from the equator. The second dimension was longitude, which is the angular distance from the prime meridian, that is the 0 degree, which passes from the London. And the third dimension is the radius. This radius, that is starting from the center of the earth to the surface of the earth. So once you can derive these three things, you can map any object on the surface of the earth in a software environment, which we will be performing in QGIS. These are toposets of different things. Now, actually, how does this may be a little critical? Let's move to the software right now. Okay, so we'll start with the software. We'll start mapping, which is the first step of the mapping is known as georeferencing. And while doing this particular georeferencing, whatever things will be there, I'll be explaining in this particular theoretical format. Moinul, can you please start sharing your screen? Moinul, can you hear me?
Yes, sir.
Start sharing your screen.
Is it visible?
So, Jai, I just want to ask you that whether you have downloaded QGIS. Oh, there are a lot of chats I've not seen. Actually, I was very much into the presentation. Everybody has downloaded QGIS. 77 participants are there, or 78. So everybody has downloaded QGIS. I hope everybody. Is there any problem with downloading installation?
Is it visible, sir?
Yeah, Manul.
Sir, shall I pause it?
Yeah, sure.
Okay.
Well,
So,
Moinul is showing you the steps right now.
okay. So
First of all,
first of
please,
all,
is there anyone, just because I'm asking you, because if you have not downloaded, then we'll continue with the slides or with the work, but it will not be done.
no, sir, I have downloaded it.
No, not you. I mean others. Any version starting from, okay, thank you, Dr. Puneet. Okay, thank you. Any version right from 3.14 to 3.34, any version. Okay, Manu, start please.
Okay. So first of all, this is the actual interface of QGIS. And whenever you open a software like QGIS, you will see this kind of interface. Might be there are some changes in different versions. It may vary from version to version. But overall, this is the interface of QGIS, and there are so many options available. So actually, if I introduce the interface part first, so these are the different options available, and you can execute different kind of activities according to your purpose and objective, whatever you want to execute. So in today's class, we will basically do a georeferencing. So we will learn how to georeference a particular map. There have already been mentioned that there are 3 different coordinates. So we will make use all of them. And now I will proceed and importing a map which we will try to georeference in this particular QGIS environment. So now to import a particular map from which are available in your computer drive. So to import a particular
Manoj, I'm
map
interrupting just for a minute, just for a minute.
Okay.
I'm just sharing the map which we are going to georeference in your WhatsApp group, okay? I'm just sharing the map in your WhatsApp group so that it will be easier for you to download and georeference it.
So if I import.
Okay, Manoj, please continue.
Yes, sir.
Continue.
So if I import a particular map which we will georeference today. So first of all, you have to go to particular options, like so many options are available over here. But first you go to the options, like you have to import the particular map. So actually there are 2 formats, like raster and vector. So this map which we will georeference in this particular session, this is actually raster format. So to import this map, we just first click on this particular button, raster, add a raster layer. So from this particular button, we will import a particular map, which we will georeference today. So now, if I import, so if I import, my map is in drive E, and the folder name, that is raw data. So under this folder, I have the particular data set which we will georeference today. So first of all, you have to open your drive, and then under the drive, which folder the maps are located, you have to select it. So our today's work is basically done over Hooghly district. So I just click on Hooghly district layout, and if I click on the particular map, then it will now select it, and just click on open and add it. So now this map is imported in QGIS environment. So if I repeat the step again, then you first have to go to the raster layer, add raster layer, then click on the raster layer. From this particular section, in which drive your map is available, you have to select it, and then you can easily import that particular map in your QGIS environment. Now, so if I proceed further, then the next step that I should follow is there are several options available, but as we are working on raster format or raster data set, then we have to go to the raster options, and then under raster option, there are several other options are available. So as I have already mentioned, our today's session is basically based on georeferencing. So I will go to the georeferencer tool and click on it. if I click on georeferencer tool, then again a new dialog box will open. And again, you have to import your particular map from this particular dialog box. How do we import it? Now, again, there is an option called Open Raster. So if you click on this particular button, Open Raster, and if you select in which folder your maps are available, then you can easily import your map in this particular environment. Okay. Then, after importing your map, whatever you want to georeference, you have to process this map. So there are few steps to proceed the georeferencing. First of all, you have to select some, or you have to add some GCPs, ground control points. So to add the ground control points, there are again options available in this particular dialog box, that if you go to this particular no, this is not. If you go to this particular option, then it is showing that add point. So if you click on this add point button, then a symbol like this will open. And you have to add some points, or we can say ground control points, as an input data to georeference your particular map. And this to execute this work, you can use multiple options. So here is the option called pan, and by using this pan button, we can move our maps according to our purpose. So now, here are the different coordinate values that are there in your map. So as you can see that there are some latitude and longitude values that are available. So actually, these are the longitudinal values, and these are the latitudinal values that are already mentioned in your map. And you have to select a point where these two particular points actually coincides. So at least you have to select 4 points to georeference a particular map. You have to take 4 points. So first of all, I will add a point from here, this particular cross section. So if I add, I have to zoom it a bit, because as you zoom the map, it will be better for you to add the input points, like add points. Then I will go to the add point button. But before going to the add point button, I will just see what are the different values. So in this particular case, the latitudinal value is 23 degree, 10 minute, 23 degree, 10 minute north. And here in this particular section, the longitudinal value is 87 degree, 30 minute east. Okay. So I will have to provide these values whenever I add a particular point. Okay. So now I will add a point. So make a click over here. Whenever I make a click on this particular section, again a dialog box is open. Now you have to provide the input that I have already seen in the form of X and Y. So now in this particular point, for this particular point, your Y input is 23 degree, 10 minute, 0 second north. So for Y, we have to input like 23, then you have to make a space, and then again 10, then again 0, 0 for Y coordinates or latitude. And then again, we have to provide the X coordinate for this particular section. So the x coordinate is, if I use the pan button, the x coordinate is okay. I will repeat this process from the past, from the beginning. So our northern value is 23 degree 10 minutes, and our easting value is 87 degree 30 minutes. Okay. So now I will provide this value as an input. Okay. Make a click over here. Then again 23 degree. Okay. I am just provide the value. Just a minute. Yeah. So it is actually 23 degree 10 minutes north and 87 degree 30 minutes east. Okay. So 23 degree, then make a space, then 10, then 0. And for east, you have to provide the value 87 degree 30 and then 0. And make a click on OK. Now, so our first point is now I have provided the input for the first point. Okay. Now I have to provide the input for the second point as well in the same way. So to do that, I have used the pan button. And then if I zoomed out, and I will provide this point as my second point. So in this particular case, our northern value or latitudinal value is 23 degree 10 minutes again, and our easting value is 88 degree 30 minutes east. So I will provide as a input. Again, these values I will provide as a input. So now, if I zoomed in, then make a click over here. Again, this dialog box will open. And if I provide the input, it's like 23 degree 10 minutes. Okay, so 23, then make a slash space, sorry, then 10, and then 0, 0. Okay, for east, it is 88 degree. Okay, and then 88 degree 30 minutes. So 30, and then 0, 0. And make a click on OK. So now our second point I have given as an input. In the same way, I will provide the third point as an input. So to do that, I will use this pan button, or you can zoom out the particular map. And if I consider this particular point as my third point, then again, the value of the latitude is 22 degree 40 minutes north in this particular point. And the longitudinal value is actually, again, the 88 degree.
Sir, I'm really sorry to interrupt you.
Okay.
So I think it will be a little better for us to understand the environment of this app first, and then go ahead with marking the marking of coordinates. And also, can we have a little background as to what exactly are we trying to do by marking these coordinates?
Actually, whenever we are adding this particular input point,
Manul,
yes, sir.
Can I say Manul?
Yes, sir.
Hello, ma'am. Actually, that was what I was asking, that whether I actually don't have any idea about how much is known to you. So let's just do this exercise. Let's just do this exercise. This is known as georeferencing. I'll be telling you that there are two questions I'm seeing on the screen. Number one is how to decide where the first and the second points will be. I'm going to answer that. And then there is a question that is there, say for example, there is a disease condition, say for example, anemia or leprosy. So how the geospatial analysis is going to help? We are going to answer it, but let's complete this small exercise and then we'll be going into it. Okay. And also, it's obviously required that what is the motive of this? I mean, why we are doing this particular georeferencing will be just be explained. But first, we have to complete this exercise because with your questions, thankful that you have written these questions and you have also asked this. Otherwise, it's quite difficult for us to judge that how much is known to you. Okay. And how to find any maps of Hooghly? It's not there. I've shared it, but maps can be found from various environment. We'll be talking about it afterwards. Okay. Just another 10 minutes we'll be completing this exercise. It's better that if you repeat this task with us, then it will be easier for you to handle the software. Otherwise, it will be difficult. Thank you. Manu, please continue.
Okay. So in the same way, I will add the third point as my input. And again, I will make a click on this particular option called add point. And then I will provide this point as my third point. So in this particular point, our northing value is actually I'm just seeing the northing value. So 22 degree 40 minute is the northing value, and 88 degree 30 minute is the longitudinal value. Okay. So now again click on the add button and make a click on here. Provide y input 22 and then 40 0 and for x coordinate we have the values of 88 degree 30 minute 00 second. So now the third point is also been provided as an input. Now I will, in the same way, I will provide the fourth point as my input. So again, if I make a click, if I select this particular point, again this is 22 degree 40 minute north, and the longitudinal value is 87 degree 30 minute north. Okay. So this particular point actually okay. So our northing value is like 22 degree 40 and then 00, and for east it is like 87 degree 30 minutes. 87 then 30 00 second. So now I have already provided the 4 point as my input point or down control point by using this particular option called add point. Now I will make a click on the georeferencer toolbar to execute this particular process. So again, you can see that if I make my cursor over here, then start georeferencing options are showing. So I will just, but before that, I have to assign some transformation setting, okay, to before proceed with the georeferencing. So under transformation setting, there are some options and I have to select these options accordingly. For example, several transformation types are available over here, but for this particular case, we will use polynomial 1 as our transformation type. Again, resampling methods are there. Target SRS, that means there are two coordinate systems. One is geographic coordinate system, another one is projected coordinate system. So we have to provide the geographic coordinate system as our default for target coordinate system. That means this is our geographic coordinate system. And then you have to provide the location in which you want to save your output. So you have to provide the folder name, or you have to provide the location where you want to save your output. So now, if I select this particular folder to save the georeferencing image, and if I named it as a georeference underscore map and save it, okay. Now click on OK. Now I will go to this particular option called Start Georeferencing, and then our georeferencing will start now. So if I minimize this particular dialog box, a georeference map has been added to your interface, and this map actually I have georeference. So this is our original map. In the below you can see that this is the original map and this is the georeference map. Okay, and here in this particular georeference map, our target CRS or target coordinate system actually in the geographic coordinate system. Again, we have to convert this geographic coordinate system to projected coordinate system. But I think it is better to understand the theoretical part before I proceed to the
Yeah, Manul, we have to understand, we have to get it from the base. Manul, once you please move your cursor.
Yes.
If Manul is moving his cursor, you can see at the bottom that there is something written known as coordinate, and there are some values 87 point something and 27 point something, and which is moving. Manul, just move it, move your cursor. So it's moving, okay. So what is the objective of georeferencing is that you can take any kind of scanned image, any scanned image, say even you can take a photograph of yourself through your mobile, and you can just transfer that JPG within it, okay. But that is not going to be a map. So the basic definition of a map comes with the coordinate systems. That means it should have some coordinates. Whenever you are calling an Uber, so you are standing at the particular location, your mobile is fetching that particular location. That is what I was saying, that the three axes, x-axis, y-axis, and the z-axis, which are actually metaphoric to latitude, longitude, and the data. So until and unless you have a coordinate that where you are standing, the Uber cannot locate you to fetch you. I mean, the Uber cannot come to the point that you actually want to. Okay. So this is actually what is known as georeferencing. Georeferencing means for everything, whatever we do, say for we are using a graph, say for example, and we have two axes, x-axis and y-axis, and we want to locate a point, say 4 and 3. So 4, 3 locating on the graph, that means we'll be moving 4 units along the x-axis and 3 units along the y-axis, and then we look at a coordinate. So that's what graphical representation is. So every time we use our reference system, so here georeferencing actually means it is geotagged. That is, we are referencing it with respect to the surface of the earth. But I'll be starting with a theory because I never knew that, I mean, I never knew what actually is known to you. So I'll be starting with a theory regarding the rasters, vectors, images, and what we can do and what geospatial technology is all about. So, Manul, I'm taking it from you right now, okay?
Okay.
Okay, okay. So, again, we'll be coming back to this exercise. We'll be coming back to this exercise. So basically, the motive of georeferencing is to reference any scanned image with respect to the surface of the earth. To reference any scanned image with respect to the surface of the earth. So let's take a very easy kind of presentation. Is my presentation visible? Yeah, I hope. So let me start with this picture. This is a picture which is being taken from the space. And you can see that you can very easily identify, I hope, that this is Africa. This is parts of Sahara Desert. This is actually the Sahara Desert. This is Europe. This is the Atlantic Ocean. And here is the night time right now, the sun, due to the movement of the sun. And here is the daytime still now, still there. So what we basically do, previously mapping was very, something you have to go to the field, you have to do everything by surveying with instruments, and then you have to get the data, you have to get the trigonometrical parameters, you have to get it down with the spherical trigonometrical concepts, because the Earth is a sphere, so normal trigonometry is not going to work over there. So the spherical trigonometrical concepts has to be included within that to get the surface of the Earth, that is a three-dimensional surface, to a two-dimensional surface, and then map it. With the span of time, there came a technology which is known as remote sensing. Now, what is remote sensing? Remote sensing is such a branch of science which deals with interpretation of object without being in physical contact with it. Say, for example, when we operate a remote, to say this is a remote for my AC, I can just switch on my AC and switch off my AC right sitting at my seat. I don't have to move. So previously I have to move. Say, for example, right now we can change the channels of our TV just sitting at our sofa. But previously we have to change our channel. I am 40. I don't know whether anybody has the idea of moving the channel, so on, first channel, second channel, etc. But right now we can do it with the help of the remote. So now what happened is that these are the satellites. These satellites acquire data from the surface of the Earth. So this is the process of acquiring the data from the surface of the Earth. And this satellite then sends the data. So how does it actually gather the data? So sun is basically the source of energy. So the sun provides, so it's basically the electromagnetic spectrum from in which there is a visual part, which is a visible part that we can see. It's having a wavelength of around 0.4 to 0.7 micrometer. Then there is a TIR part, that's what we feel the heat for. Then there is a near infrared part, which is not visible to us. Then there are UV rays, again, it's not visible to us. So there is a long electromagnetic spectrum in which we can see just the visible portion, okay? So from this visibility, we're taking the help of this particular visibility, and also from others, from this NIR, TIR, etc. Actually, the satellites gather the data. The satellites gather some data. That is the spatial data. Now, this data is being sent to a receiver in the surface. I mean, it's for India, it's in Hyderabad. They receive the data and they process it in a computer. And the total science that we deal with is known as remote sensing. So now we can get the live data, in fact, live data. Previously, once you map it, say, for example, I was doing a work in the areas of Newtown, Kolkata. So when I started doing my work, I got some topo sheets. These topo sheets are the old maps. And they were actually mapped in 1970. So they were showing wetlands. Now going to that particular area, you know it, no more a wetland. It's a high rises coming up everywhere. So with the help of remote sensing, I can get the data of the last month. Even I can get the data of a few days back, in fact. So that's what help us managing data or mapping. So this is basic technology. I'll be going very first through this. So that's what I said, that is the solar energy comes in, it's get reflected back, it's being absorbed by it's being sensed by the satellite sensors, and then we gather the data and do whatever we like. So there are two types of remote sensing. One is known as this active remote sensing, another is known as the passive remote sensing. This active remote sensing is something, if you have seen the film Uri, then you can correlate with that. Passive remote sensing is something when we have the sunlight gets reflected back to the satellites, they gather the data, they send it to the receivers, and we then process it. But at the night time, say for example, right now over here in Kolkata, it's around 8 o'clock, and we don't have any lights over here, so satellite cannot sense it. So it have to send some energy of its own And then they collect the data. In that case, it's known as an active remote sensing, just like using a torch in an area where you don't have any kind of lights. Okay, so this is known as active remote sensing. Passing on this, so these are actually the sensors of the satellites. These are actually the sensors of the satellites which collects the data when the sun rays are being reflected back. So if I look at this particular sensor, see there are four what I say, camera like things, lens like things. Okay, lens like things, they absorb this data. Now how they absorb this data, they actually, what they understand wavelengths. Okay, they understand wavelengths. Say for example, this camera is fitted to absorb only the red band. This camera is fitted to absorb only the blue band. This camera is fitted only to absorb the green band. This camera is fitted only to absorb the inner band. So that is the electromagnetic spectrum, and that is how we gathered that particular data. Okay, maybe it sounds a little bit confusing, but I'll try to make it clear as much as possible. Well, there are two kinds of satellites. One is known as the geostationary satellites, another is known as the polar orbital satellites. That means, say for example, my visibility is on. So say this mobile is the Earth, and it's rotating always, it's rotating. And say for example, the key of my car is the satellite. So two types of satellites are there. One is it keeps on, if this is the surface of the Earth and it keeps on rotating along with the surface of the Earth, it just looks at a particular area. So this type of satellites are known as geostationary satellites. For example, say previously, say 15 years back, 20 years back, when there were cyclones, there was a lot of casualties. But say in the last 5 years, there has been a lot of cyclones. There were cyclones like Fani, there has been cyclones like, I forgot the name, but there are a lot of cyclones. But there has not been a single casualty, neither in West Bengal, nor in Odisha, nor in Andhra Pradesh. What for? Because when the satellites are overviewing the Earth's surface, and constantly they can see how the eye of the cyclone is moving. What is the speed of that particular eye of the cyclone moving? What is the time? They calculate that. I mean, I can also calculate it. And by what time the eye of the cyclone is going to hit the land portion, because nobody is going to reside on the sea. So once it hits the land, there will be some devastating effects. There may be some hazards and disasters. And those hazards and disasters are being reduced by removing every individual from the coastal areas, And even just by, just doing some calculations or looking at the capacity of those cyclones, we can guess that what can be the speed with which, or what can be the velocity with which the cyclone is going to hit the land. We can calculate that so that we can remove all the persons from there. If it is a depression, we are not going to remove anybody. If it is a cyclone, we are going to remove persons so that there are no casualties. So remote sensing has brought these changes, that there can be no casualties in case of cyclones hitting the coastal areas. Another type of satellites are there, which are basically, so these are geostationary satellites, what I was talking about. So once the satellite just sees this portion of the Earth. So every time there is a movement in the atmosphere, we can cover it, and accordingly we can say that what to do, we can plan out evacuations. We can reduce the disasters or the hazards. The next type of satellites are these polar orbital satellites, so the sun synchronous satellites. What happens in this case? If this is the Earth, again, if this key is considered, say, for example, say the sun is actually not moving, but let us consider the relative motion of the sun. Okay, so the light goes on like this. Sun synchronized. That means whenever there will be sun ray on the surface of the Earth, the satellite will be collecting the data according to the local time of that particular area. So they'll be continuously collecting the data. So if this collection of the data goes on, say for years after years, say for 20 years, 30 years, 40 years, so you can easily understand what are the changes that are taking place over that particular area. So for example, as I said, that Newtown was an area which was mostly marshy. There were mostly wetlands. And say it was a data taken 10 years back, 15 years back. And now you go over there, it's completely a built up area. It's completely full of flats and big buildings. Even not only that, you can even calculate that how rapidly the changes are being taking place. I mean, what is the intensity with which the built up areas are increasing? In fact, along with this, we get the data of the TIR, that is a thermal infrared, and we can calculate the LST for that. What is LST? LST is the land surface temperature. So for example, there was a vegetation cover, so obviously the temperature was going to be less. And now there is built-up area, so the temperature is going to increase. I don't know how you, I mean, maybe these things, the change of temperature, the change of ecology, change of biodiversity of a place, may affect the, I mean, illness, may affect facts where we feel ill or sick and we go to you, which may be correlated with these facts and figures. Going into the details, I'll be going very first. So now, whenever you take a photograph with your mobile, say for example, or if you use a DSLR camera or any digital camera, you know, the photographs consist of something which are known as pixels. The photographs consist of something which are known as pixels. So basically, when we download an image, I will show you some portals like Vunidi, Vuvan, etc., from where you can download image of the whole of the earth and you can map it. You can not only map it, you can get a lot of data, in fact, and you can use it according to your requirement. I don't know what maybe your requirements actually. You can map them, you can correlate them with the disease that are taking place in a particular place. Say people are suffering from, say for example, in a particular place in North Kolkata, people are suffering from malaria, say for example. And you want to find out that what may be the basic reasons that people are suffering so much from malaria in this part of Kolkata. I mean, the whole of Kolkata is very homogeneous in nature. Why it may happen like this? So go to the portals, download the images, get it ready to work out with many parameters as you want to. And if you can correlate that with that, I mean, the disease with the parameters, you can be getting good results for that. Anyway, so there are 4 kinds of resolutions of a particular image. Whenever you click an image by your mobile or your DSLR camera or SLR or any digital camera, you get 4 types of resolutions. What are the resolutions? Number 1 is the spatial resolution, which is defined by the pixels, the number of pixels. If you go on increasing if you take an image and just go on increasing it, you will find some pixels over there. That is, pixels are known as basically picture elements. So if the resolution is better, the pixels will be looking like this. Say, for example, there are certain kind of satellites, IRS-1, IKONOS, ResourceSat, and they have taken the pictures like this. Okay, so what are the differences of the pixels? Say, for example, let me show you this picture. This is an image taken from a satellite which has got a resolution of 60 centimeters. That means every pixel is just a square. So that one side of the square will actually correspond to 60 centimeters on the ground. So just look at this photograph. Now, this is not a photograph, this is an image, and this has been taken by a satellite. This has been taken by a satellite. So you can even count the number of vehicles standing over here. You can see how lashy the part of this field is and how barren this type of field is. You can even see where are the water bodies, where are the roads, everything you can cover it from here. But only a true color resolution of these, and when I see this, it's okay for a layman. But for a scientific research, this is not sufficient. For a scientific research, this is not sufficient. So actually, what do we do? As I said, that this total area will be divided into some pixels, and we'll be gathering the data. And what is my data actually? My data is actually the wavelength of the solar energy, which is being reflected back from the surface of the earth. So how do I gather my data? I gather my data like this. I gather my data just like this. Okay. So if this is my real picture, the computing at the back of the data is like this. The computing at the back of the data is like this. So what are these? These are pixels. So these are square boxes, which you can see. And there are some numbers. And there are some numbers, and this is known as radiometric resolution. I'm coming to that. This number will start at 0 and end at 255. Why so? I'm coming to that. Okay, so this is the real computational part. That is what the computer actually understands, because computer understands only digits. Computer doesn't understand anything else other than digits. Okay. So here are the spatial resolutions. So the image of the same area being taken, one has got a spatial resolution of 30 meter. That is a pixel side. The one side of the pixel will be representing 30 meter. The same photograph has been taken by a different satellite. One side of the pixel will be represented by 4 meter on the ground, and this is one side of the pixel will be represented by 0.5 meter on the ground. So obviously, when you are taking this one, it will be having a better resolution. Say, for example, you go to a shop and you want to buy a camera, and you want to say there are two cameras. One is having a 50 megapixel capacity, another is having a 80 megapixel capacity. So obviously, this 80 megapixel capacity is going to cost you high, because say I have a camera of 11 megapixels, so it will look like this. A 50 megapixel camera will look like this, an 80 megapixel camera may look like this. So with the improvement of the megapixels, the DPI increases, that is the dots per square inch, and the resolution gets better with that. I'm coming to this, but before that. So what the computer understands, I must understand that is what the computer understands actually. Whatever you do, whatever you say, for example, you have taken a photograph of your own, you take a selfie of your own, you import that into the computer, but what the computer actually understands. The computer understands these radiometric resolutions. What is that? So for example, previously, when we don't have very good cameras, and I mean, not the cameras with the films, the cameras with a digital capacity. Say I'm taking a photograph of 1 bit. So what is that? The equation stands 1 bit is like 2 to the power 1. So n bit, that is 2 to the power n. So if it is 1 bit camera, so if I take a photograph of this particular room, I'll be getting the values either in black or in white. Whatever I'll be getting it either in white or in black. So for example, 1 bit camera, it's 2 to the power 1, so the total value is 2, so it will be divided into either 0 or 1. So now if a camera is a 4-bit camera, so it will be around 2 to the power 4. That means 2 to the power 4 is 16. So it will start at 0. Anything? So it will start at 0 and end at 15.
Very nice.
Will start at 0 and end at 15. Okay, and that means now see, previously there was only 2 shapes. Is somebody saying anything?
I'm very fine. Happy birthday. Thank you, Auntie. Thank you, Didi.
Somebody is wishing happy birthday to someone.
Rachi Didi. She sent you that cake, no? Yeah. So tell her when you will come to visit us. When will you come to visit us? After my exams are over, I'll come.
Please, can you please mute your?
When will your exams start?
Please.
My exams are going on. Right now? Yes.
The host can mute.
My exam starts on the 24th of February. I
Yeah,
know.
just a
I'm
minute.
continuing. I'm continuing. Anyway, I'm continuing. So it's 2 to the power 4. That means.
Okay.
So it's 2 to the power 4 means it's a 16 size data. Okay. So here you see you get black, then black, then black suddenly turns up to gray, and then it's absolutely white. So you get 16 shades over here. Now the satellites what we are having right now is either 8-bit, 10-bit, or 11-bit. So how many? What is the range of the data? The range of the data is 2 to the power 8. That is 256. So your data starts at 0 and ends at 255. So any box which represents a 0, that means it's absolutely black. And any box which represents 255, it's absolutely white. So that is the computations. Actually, the computer understands. That is the computation the computer understands actually. So if I take the same photograph, say for example, this is a 2-bit photograph taken by a particular camera, and this is the 8-bit photograph taken by a particular camera. So this is the difference we are going to have. This is the difference we are going to have. And accordingly, this is what the computer understands right now. See, here all the pixels will be having some black, gray, white kind of sets. Here black represents absolute 0 and white represents 255. So whatever number, whatever digits you will be having over here will be varying from 0 to 255. It will neither be less than 0, neither it can exceed 255 if the satellite sensor is a 8-bit satellite sensor has a 8-bit capacity. It may extend up to 11-bit capacity. Okay, so this is how the satellite takes the data. So number one is the spatial resolution, what I showed you. That is the 60 centimeter spatial resolution. Number two is this radiometric resolution. So this is how we capture the data. Okay, this is how we capture the data, is the radiometric resolution. Number three is the spectral resolution. So what is the spectral resolution? This is quite interesting. So this is actually the wavelength or the solar radiation, in fact, what is known as insolation. So what we get over here, we get some gamma rays, we get X-rays, we get ultraviolet rays, and this portion is known as the VIBGYOR, that is a visible rays. Then are the infrareds, then radar image, the radar data, then FM what we hear in radio, then is the TV, then short waves. These things goes on. So the wavelength increases right from the left to the right. So the wavelength increases a lot. So these are the macro wavelengths, in fact. And these are the visible lights. And these are the visible lights. That is only this portion. That is what we can see, what we can actually see. But the fact is, say, for example, if you have gone through the images, say, for example, if you have gone through the images of Sundarbans or Andamans, or many a times it's being given in the newspapers also, the vegetation in these areas looks red. Well, I'll go into that maybe in a next class. So this is the visible spectrum. This is the visible spectrum. What happens in a camera whenever we are taking a photograph? Say, for example, I am taking a photograph. My data is limited to this visible light. My data is limited to this visible light. But when a satellite is taking a photograph, it's not restricted to the visible light only. It can gather data from this infrared. It can rather gather data from the TIR. It can gather data from the radar waves also. Okay, so the radar data, in fact. So it's not that whatever is being taken by the help of a mobile or a digital camera, it's equivalent to what is being taken by the satellites. The satellites have the capacity, not absolutely not equivalent, but the satellites have the capacity of gathering the data from a much wider spectrum in this particular wavelength, this solar radiation. And finally is the temporal resolution. As I said, that the satellite just goes on revolving like this. So once the satellite goes on revolving like this, the temporal resolution means, so say, for example, a satellite is collecting data. Say it's Tamil Nadu, then Andhra Pradesh, then Maharashtra, Madhya Pradesh, and then Uttar Pradesh, and then Himachal Pradesh, Kashmir, and it goes back and it comes after, say, 20 days in the same line. It's in the same line. So that is known as the revisit time of the temporal resolution of the particular satellite. So here where we divide this data into two categories, one is known as the raster data, another is known as a vector data. So what is the raster data? So just look at this particular picture. This is a raster data. So any data which is composed of pixels, which is being taken by the satellites, or basically the sensors, or anything. Say you have a scanner at your home, you have a map of your own, and you just scan it. So whenever you are scanning it, you are getting the data in the form of the pixels, and that is known as the raster data. Okay, so that is known as the raster data. And whenever we want to generate any, say, polylines or polygons, or say any kind of line or any point over a particular map to do some kind of spatial analysis, that is known as a vector data. So data is primarily divided into two kinds. One is known as the raster data, another is known as a vector data. So raster data composed of pixels and vector data composed of lines, points, and polygons. Okay, line, points, and polygons. Now, what is our primary objective? Now, what is our primary objective? Whatever data you are gathering, say for example, you have seen a lot of drones being used nowadays. A lot of drones being used. Now, a drone can take a photograph. That is okay. Taking a photograph in a marriage ceremony is a different thing altogether, and taking a photograph for doing research is a different thing altogether. So whenever a drone is taking a photograph, until and unless you relate that to this particular photograph to the coordinate systems of the Earth, that is unless and until you georeference, what Moinul was showing you, that is georeferencing. So you are referencing it with respect to the geoidal coordinates. So what are the coordinates? As I said you, this is also over here. As I said you, this is also over here. So what are my coordinates? My coordinates are, just remember, this is the shape of the Earth. So that is the challenge you are going to take. That is the challenge you are going to overcome maybe by the next 5 classes. So this is the condition. We are doing something we absolutely in a 2-dimensional surface from a 3-dimensional surface. Again, this particular 3-dimensional surface doesn't have a very well sphericity. The eccentricity changes. It's a sphere where the major axis and the minor axis are again not very coincidental. Okay, so the major axis does not like. I cannot say that the major axis lies over here and the minor axis lies over here. It's a 3-dimensional figure which is being defined as the equipotential surface with respect to gravity. So it is not defined with respect to any kind of geometry. Okay. So if you just look at this particular image, if you look at this particular figure, so if this is the shape of the Earth, this will be, if this green line represents a geoid, that is the equipotential surface with respect to the Earth. Ellipsoid is something, again, a different concept altogether. I'll tell you that thing afterwards, but you need to know that for mapping. You need to know that these are not things very critical. You do a lot of critical things. These are very easy things, in fact. But we have to learn these things in order to do the map. So again, I'll be asking Moinul to repeat the steps of the georeferencing, and I will request you do it yourself. You do it yourself. Once or twice, there may be confusions, but you will overcome that. And once you learn that georeferencing, then only we can move to the spatial analysis. That is the basic of that. That is the ABCD of doing the spatial analysis. If I don't know georeferencing, I cannot move on to the spatial analysis. These softwares are embedded in such a way, once you input the data, you use statistics now. You use a lot of statistics. You use data from anywhere. I'll show you portals from where you can download the data. You can even get the census data, you correlate them, you work out for your journals, and you can also correlate them with the kind of diseases that are happening in a particular place. So for example, latitude-wise, the diseases may change. The diseases may change in a latitudinal way, the diseases may change in an altitudinal way. I'm not an expert of that, but maybe there can be kind of correlations to deal with. And you can also advise some kind of precautions or the measures that can be taken with the help of this spatial analysis. So I am requesting Moinul to again start with the georeferencing. You do it. If there is any question, you can please ask.
So just one quick question, just to confirm.
Yeah.
So I'm new to this. So this raster data is only relating to spatial resolution, right? So
Which
it's not the raster data set, raster data format.
Yeah.
It doesn't include radiometric or spectral, that information, right?
No, that particular raster data set, sir, if I want to explain, you say, for example, just let me open it. Very soon. Just a minute.
Sure.
কোথায় চলে গেল রে ভাই? Screen is not coming, boy. See, I'm telling you, these data are very important. You just understand the robustness of the data. Say, for example, a satellite sensor is capturing a data with a resolution of 5-meter resolution. So each pixel will be defining 5 meter by 5 meter on the ground. Okay, that is okay. Right. 5 meter by 5 meter on the ground. Right. Next, it will be having 2, 3, 4, 5, 6, 7, or maybe nowadays there are even 11, 12 bands. What are these bands? These are the wavelengths. Okay. That is the spectral resolution that I just showed, that the visibility per VibGeo. So there may be red band, green band, then there may be blue band, there may be TIR, etc. So there are a lot of bands, okay? Right. So that particular thing that I showed you, say, for example, this one, where is my presentation? So this will give them the bands. Okay, number of bands. Okay, And now see, each band will be having these radiometric values.
Right. Okay.
Okay. So say you have gone to a shop and you want to buy a blue color shirt.
Right.
And now expect that the shopkeeper is showing you 256 bands of blue.
Right.
That 256 will actually be reflected over here.
Right. So what I'm asking, like in that pixel that you mentioned,
Yeah,
so that raster file not only has information about the dimensions, but also all these other characteristics as well.
absolutely.
Got it.
See, the computer does not understand this color, wavelength doesn't. The computer understands digits on its own, right?
Right.
So these have to be converted in a way. Oh, I forgot to tell you one thing. Thank you for your patience. These are actually known as DN values, digital number values, with the help of this radiometric resolution. With different bands, say for example, a satellite sensor has a capacity of capturing 4 bands. So all these radiometric resolutions will be embedded within this in a say this is a blue color band. This is only for blue color. Then is only for red color. Then is only for green color. And these are embedded. These are stacked.
Okay.
And
got
then
it.
the combinations will give you the values. And therefore, remote sensing is so, I know, it's something very important nowadays.
Right.
You can do a lot of things. Okay.
Great. Thank you
So
so much.
let's start with the procedure with generating the georeferencing, because once you do it on your own, okay, you will get the confidence and you can just go on with the software. Because these are open source platforms, you can download the help file and you can do a lot of things. In fact, just let us start with that. Manul, are you there?
Okay.
Manul, please again you start. Can we repeat that georeferencing steps once again, and you please do it with us. I know some of you already know this georeferencing, but whoever has not done it before can repeat it with us. Manul, please,
Yes,
over to you.
Also, sir, if you can show how to remove like a falsely created data point, can we delete a data point?
Yeah, obviously, whenever we are doing it, see, sir, whenever we are doing it, obviously we are going to make mistakes.
Right.
And he must be showing you. Manul, please start.
So is it visible? Is it
Yes, sir,
visible?
it is visible.
Okay, thank you. So now I will again repeat the whole process. How do we georeference a particular map? So if I want to georeference a particular map, but before doing this, you have to first understand the several options that are available in this particular environment. So whenever you open a software like QGIS, this kind of interface you will see. So here are the options called project. And from this project button, you can import the data, whatever you want to input. If you have already done a particular project, you can input that particular project from your environment from this section. There are several other options that we will explore in the next few classes. Then there is a edit button, and from this particular button, or by using this particular button, you can make some editing. Like there is a button or option called view. This particular option is quite important, and if you require any particular specific tools that are not actually showing in your interface, then go to view, and from this view menu, you go to the panel and make a check on this particular set of options that you want to work with. Again, from this toolbar option, there are several other options, and according to your purpose or objective of study, you may check or uncheck this particular option. If in your QGIS interface, the georeference toolbar is not showing in the raster button, then you have to use a particular option, or to install this georeferencer option in your particular QGIS environment, you have to go to the plugin option. And whenever you go to the plugin option, there are two other options are available. So under plugin option, there is an option called manage and install plugins. And by using these particular options, you may end up with adding a number of plugins that are developed by different researchers. Okay. So if the georeferencer toolbar is not showing under the raster dataset in your QGIS environment, then you first go to the plugin and then manage and install plugin. So if you make a click on this particular button, then this kind of dialog box will open. And here you have to make a search that what kind of plugin you are actually want to import. Okay. So now if you in the recent version of the QGIS, like whatever I am using, so this particular version of QGIS 3.22.11, here the georeferencer toolbar is already inbuilt with the software. But there are few other versions in the QGIS, like in the older version of QGIS, you may have or you may not be that these georeferencer options are not available. Okay. So to import the georeferencer option in your QGIS environment, you make a search on georeference. The first letter of the georeferencer should be in capital. Georeferencer. Georeferencer GDAL. Okay. So georeferencer GDAL. You have to make a search on this. As in my computer, it is already installed in the QGIS environment and it is already showing in raster under the raster button. So it is not need to install again. But whoever facing this issue that you don't have georeferencer option in your QGIS, then you first go to the plugin option, make a search on georeferencer GDAL and make a click on the install button in that particular dialog box and it will add it to your system or software. Now, so first of all,
excuse me, sir.
Yes.
Sir, only georeferencer extension is there.
But I think under your raster button or raster option, the georeferencer tool are available.
It was not there.
Okay. So if it is not available, then again you go to plugins. Okay, I'm just showing you. Actually, the problem is this particular software is highly highly dynamic and it's updated from time to time and it's renamed the plugins as well. So earlier it was like in the name of georeferencer GDAL, but I think the name of this plugin has been changed right now. So if I make a search on georef, okay. Yeah. So georeferencer extension is available over here. So you select it and install this plugin and then see what happens. It will come under raster button or not. If it is not, then I will again show you. Okay. So just make a click on georeferencer extension.
Sir, it is not coming.
Okay. So that means there are some other plugins or there might be some problems in your installation. Sometimes it may also happen that if installation is
What
not
is your
properly
version?
done.
What is your version?
Sir, it is not coming in mine
Sir,
also.
3.30.
It is always better to install a previous version. That was I was saying. But 3.30 it should come now extension.
Sir, extension is coming, but
This georeference extension is
But-
not coming.
sir, extension in the plugin button it was coming, but in the raster it is not showing.
Yes.
No. First of all, actually, what happens? No, these are open source softwares. Actually, when you purchase a software, that is a different issue altogether. So, since it is an open source software, so sometimes we have to just install these plugins. Okay,
You
these
have to
plugins are
install
nothing
this
but
plugin.
extensions of the applications.
Sir,
Sir, in the
install-
plugin option, actually georeferencer extension is there, but the
Yeah.
georeference equal is not there.
georeference extension and then just install
Install
plugin.
Yes, sir, I have
Install this
installed
plugin.
it, but it is not showing in the raster option.
Yes, same problem, sir. Here also.
There might be some problems if your internet connection is not well, then it may appear, it takes some time, okay? Or you may restart your system and then again open your QGIS environment. It may happen sometimes that this kind of errors are occur, okay? So try to install this plugin. I think it will be under raster environment. First, you restart your system and then again open the QGIS environment, okay?
If
So
it is
now,
not coming, if it is not coming, then we'll look into the fact, okay?
for those who have already installed the georeferencer plugin, or for those who have already made their georeferencer plugin are working properly. So first you go to the layer panel, because as I have already mentioned, or sir have also mentioned, that you have to first import a particular data set to make a georeferencing. So first you have to add a layer. So by going to this particular option layer, you may add different types of data, like you may add raster data, you may add vector data, you may add CSV data or Excel data. So you can add different types or several types of data from this particular section, add layer section. There are some shortcuts as well. So here in this particular, in the left button, there is a square box, and if you make your cursor over here, then it is showing that add raster layer. So by clicking on this particular option, you directly import your data from the computer drive that are available. But if you want to import your data from this layer button, then go to the add layer and then click on the add raster layer. Again, a dialog box will open, and you have to select in which particular folder or in which particular drive your data sets you have already saved. Okay. So if I go to my drive, then it is available in the E drive, and under E drive, there are several other folders, but the data is actually in the raw data folder. So if I click on this, and this is my original data, and this was the previously done georeferencer images or georeferencing images. So I will import this particular data set, this original data set again. So make a click on this particular data set, select it, then click open, and then add it. So it's a very simple process. You just go to the layer panel, then go to add layer. From add layer, you go add raster layer. Then a dialog box will open, and from this dialog box, in which folder or in which drive your data sets are saved, you just select that particular data set, make a click on open, and then add this particular data. Okay. After importing this particular data set, there are several latitude and longitude values. Okay. But as I have already mentioned in the previous time, that you have to take at least 4 points to properly georeference a particular map, and it depends on the transformation type you are basically using. So fundamentally, we are used 4 points to make a map to be georeferenced. So for this particular map, if I want to georeference this particular map, then I have to take 4 points, and these 4 points should be from equally distributed. These 4 points should be equally distributed over the map. It will be better. Okay. So I will take 4 points from the 4 corners of the map.
Well,
So
I'm just interrupting for 1 minute.
Yes. Yes.
Just one.
Okay. Yes.
One thing I would just like to correlate with the theory. See, for example, this is a map which is either downloaded or scanned. This is a map which is either downloaded or scanned. And when I open this map, this is known as catalog tree on the left-hand side. This is known as catalog tree. And you can see it that there are three things we can: band 1, red; band 2, green; band 3, blue. So this is what the computer understands. So this is what the computer understands. It's not necessary that what we understand, but this is what the computer understands. And the stacking of this layer gives you a final output like this. It may even be a black and white image. It may even be a black and white image. But whenever you open it in the catalog tree, you will be getting things like this: band 1, band 2, band 3. So this is what the computer understands, in fact. Okay. And second one is, somebody has asked a question that how to select this point, that point. It is not necessary that you have to take these coordinates only. I mean, there are a lot of intersections over here, you can see. But any 3 points, with the help of any 3 points, you can calculate, you can georeference an image. Any 3 point on the map. But you have to know the latitudes and longitudes for that. And therefore, the straight lines are being given at the point of intersection. You can understand that these are the latitudes and the longitudes over here. But any 2 point can be collinear, but the third point cannot be collinear. If it is collinear, I mean, what happens is that here is a point, here is another point. So the software will automatically calculate the graphical distance in between them, and you are giving an input of the latitudes and the longitudes. So it will also calculate the differences between the longitudes and the graphical distance in between them. So that is how it defines a scale. But if it goes on in a particular line, that is, if it is absolutely collinear, so it cannot take into account the latitudinal divisions of that. Okay. So these points have to be random. I mean, it can be either the 4 coordinates, it can be either anywhere, but it cannot be collinear. Number 1 is this. And number 2 is, you can do it with the help of any 3 points. But the fourth point is required to calculate the RMSE, that is the root mean square error that we may perform. The root mean square error we may perform. Since we are doing it manually, there can be any kind of error. So if there is any kind of error, the software will automatically help you to know that what is the amount of the error we are doing. And you can not only take these 4 points, you can take n number of points depending on the robustness of your project. Okay, thank you, Manu. Continue.
Okay. So if I continue, then ideally, as I have already mentioned, that you can make georeference by taking any 3 points anywhere from the map. But ideally, I will pick 4 points, 3 for it is necessary to take 3 points, and 1 is for accuracy assessment. So I will take 4 points from 4 different corners of the map. Okay. So if I consider this point as my first point, this particular intersection, like X and Y, this particular intersection. So here the Y value is actually 23 degree, 0 minute, north, and 0 second. And yeah, so it will start from here. So this particular point, actually this map starts from here. So I will take this particular point as my first point. So 23 degree, 10 minute is the latitudinal values, and 87 degree, 30 minute is my longitudinal values, or northern and eastern values. So I have to provide these values as input. Okay. So first of all, you have to go to the raster layer or raster option. Then under raster option, you have a option called georeferencer. You have to make a click on the georeferencer option, and whenever you click a georeferencer option, another dialog box will open, and here are several other options. As one already asked, said that how can you delete the points? So like see, this point is actually to load the ground control point that we are actually giving inputs to the computer. Then this option actually used for to save the GCPs or ground control points. Okay. Then this is the add point. By using this add point button or option, you can add the input points or GCPs. Here is the delete option, or you may delete your wrongly taken point. You delete by using this particular option. Again, there is a zoom in option, zoomed out options are available. There is a tool called georeferencer or georeferencing. So first of all, you have to take 4 points from the map. So as an input. So I will take 4 points one by one. So first, I will make a click on add point, this particular option. Okay. Oh, no, but before doing this, I have to input the map first. Okay, so this here again, our square box is available. Open raster. So first of all, you have to again open that particular data set, which you have already imported to your QGIS environment. So by clicking on this particular option, you may import your original data set that you want to georeference. Okay. No, actually this is not original data set. This is the georeference one. This is actually, I think, original. So actually, this is the original. No, this is not. Okay. Just give some time so that I can input it for you. I have to delete this first. Okay. Discard it. So now again, I will import this particular data set. This is actually the original data set, and I will add it. And from the raster tool, I will go to the georeferencer again, and then again import the particular data set that I want to georeference. Okay. So now this is the original data set that we will georeference in this QGIS platform. So first I will take this particular intersection as my first point, first input point. Okay. So here my northing value is 23 degree 10 minutes and easting value is 87 degree 30 minutes. Okay. So I will provide these values as my input. So from this add button or add point option, you just make a click on add point and then provide input for this particular images. Yeah, just a minute, just take me some time to see the values. So for Y, it is 87 degree 30 minutes, and for for Y it is 23 degree 10 minutes, and for X 87 degree 30 minutes. Okay, so for Y it is 23 degree 10 minutes. So you have to provide the input 23, then space, then 10, then 00. And your east or easting values, longitudinal value is 87 degree, then 87, 30 minutes, and 0 seconds. Then make a click on OK. So your first point, you have provided the input of your first point. Now, go to the second point. You may take any intersection, but I will take the 4 corners because it is ideal to take from the corners. Now, again, by repeating the same process, add point, I will add the second point. So here again, I have to provide the x and y as my input. So here the x value is 23 degree 10 minutes again, and y value, x value is 88 degree 30 minutes, and y value is 23 degree 10 minutes. So 23, 10, 0, 0, and x 88 degree 30 minutes. 88, 30, 0, 0. Then click on OK. So now the second point is also, you have already provided the second point as your input. Now you have to provide the third point. Okay. So by repeating the same process again, add point, click on the add point option and click on here, rightly in the middle of this cross section, and then provide the list and not value. So what actually we are doing, we are assigning the latitude and longitude values of the map to the actual surface of the ground. And this is the purpose of doing georeferencing. So here, my x value is 88 degree 30 minutes and y value is 22 degree 40 minutes. So 22, 40, 0, 0, and x value, that means 88 degree 30 minutes, 88, 30, and then 0, 0, and click on OK. So now third point is also ready. Then last point I have to take again this point as my last point. Now again I will click on this add option, add point option. Now you have to again provide x and y. So for this particular case or this particular option, your x value is 87 degree 30. So x value is 87, then 30, then 0, 0, and y value is 22, 40. So 22, 40, and then 0, 0. Oh, sorry. There is some error. Actually, if this kind of thing happen, you take it as a error. I think there is some problem to take the input points and provide these input points. Although you can proceed with these particular points also. So
Manoj, please zoom that
yes,
particular error. Manoj, please zoom
yes,
that particular error.
Yes. Yes.
Well, this is the error, okay? So if you don't take the fourth point, you will not be able to consider what is the amount of the error that we have done. And what is the value of the error? That is more or less, this is residual pixels. It is written, this is the error we have done. That is, it's 2.5 pixels. It's around 2.5. That means it has moved 2 pixels, another half pixels. So while giving these points, we should be very careful. Otherwise, some error will happen. Well, but this is an acceptable error. This is an acceptable error. While working with this, you can understand what is the approximation you can take. That is, what is the level of or what is the level of acceptance of this error? You can just take it into consideration. Well, this is an acceptable error. Anyway, Manoj, please.
Okay. Then you have to go to this setting or settings like option in the yellow button, and this is called transformation setting. And here are several other options, but we will keep this option as default and just change two options. Target SRS, that means spatial reference system, and two types of spatial reference systems are there. One is geographic spatial reference system and projected spatial reference system. So this CRS, actually coordinate reference system, is known as geographic coordinate system, and you have to provide an output folder or output name in which you want to save your output. So again, I will name it GeoRef, and as this map is for Hooghly district, so I will name the GeoRef Hooghly, and then save it. The remaining option we will take the remaining option as default option, because lots of theories are involved to how we are selecting this particular transformation type, desampling method. But you can take this particular default option and proceed with this particular.
Monil, just a minute. Well, this is again, see, we have given some inputs of latitudes and longitudes, okay? But as I started with the fact that for locating any point on the surface of the Earth, we need three coordinates. I mean, three axes, X, Y, and Z. So the first and the second coordinates. So the first and the second coordinates are those latitudes and the longitude values, that is 88 degrees something or 23 degrees something. So these are the latitudes and the longitude values. And what is this CRS? This is the reference system, okay? So this is the one, that is WGS 84, which will actually provide you with the third coordinate, that is the data. That is the distance from the center of the Earth to the surface of the Earth. So these are the three axes information we are providing to this particular image to make it or to convert it in a map. I think it's clear. I'm repeating it. We have given the informations of latitude, we have given the informations of longitude, and this target SRS will actually is the information for the data. That is the third coordinate. So until and unless we provide the first, second, and the third coordinate, no image, that is anything. You take a photograph of your face and paste it over there, doesn't matter. But until and unless you give these three informations, nothing can be converted into a map. So these are the three informations that we give to convert it into a map. Okay, Manu, proceed.
So then make a click on OK and go to the georeferencer or start georeferencing option. So if you click on this georeferencing option, then your georeferences will be started. So now, yeah, so you can see or visualize this georeference map. And if it is not showing in your interface, go to this particular, take a click on this particular images and then make a right click on it and go to the zoom to layer option, and it will now showing in your interface. And
Can
here,
you please repeat the transformation part?
yeah, I will repeat. So again, after provided all the input points or 4 input points, you have to go to this particular button, that transformation settings option, and you have to provide two inputs, right? So one is target SRS, and here in this particular case, I am assigning a target SRS, that means EPSG 4326 WGS 84. This is your target SRS that sir have already explained. And you have to provide output raster in which folder you want to save your output. So you have to assign that particular folder that you are want to save your output to that particular folder only, and then make a click on OK. Okay, and whenever you make a click on OK, your georeference click on OK, and you have to go to the start georeferencing button, make a click on start georeferencing button, and your georeferencer will be started, and it will automatically uploaded in your interface QGIS environment. If it is not visible to your QGIS environment, make a right click on this particular layer and zoom to, make a click on zoom to layer. It will be visible to your screen. Okay, so this is the point, and now you can see that in the below coordinate, the coordinates are actually showing. So if I move the cursor over the screen, then the coordinate values are showing, but actually these values are actually showing in few numbers, right? So like 563141, 2486307. If you want to convert these values into degree, minute, second, as our input point was in degree, minute, second, so just go to this particular settings, EPSG 32645, make a click on here and go to the general section. Here under this general section, you have to provide degree, minute, second as your format, and by selecting degree, minute, second, you have to click on apply and then OK. Now your coordinate value is showing in degree, minute, and second. Like as I have input, I use this value as my input to georeference this image. Okay, so this is the process by which we georeference a particular map or images, and few steps are involved. If you have any doubt, you can ask me again. I will repeat.
Can you repeat
Excuse
the
me, sir.
last part?
Last part.
Yeah.
Yeah. So now, first you have to provide the input points. You have to provide your transformation settings. After transformation setting, under transformation setting, you have two options. One is target SRS. You have to assign your target SRS like this EPSG 4326 WGS 84, and you have to provide a folder in which you want to save your output. Then make a click on OK.
So, sir, hold on, sir.
Okay.
Sir, so
Okay.
like every time we have to select that target SRS at ending by
Yeah,
84.
yeah.
So this remains same.
Yes, this remains constant.
Madam, this target SRS is something that I will explain you the next day. Okay.
Okay,
I
sir.
mean, there are a
Okay.
lot of target SRS.
Yeah.
Just for today, for
So-
your normal understanding, take this one. Normal understanding.
Yes.
There are a lot of
So
target
actually,
SRS.
I was not able to appreciate like what is target SRS. Maybe we'll wait for the second
Absolutely. I
session.
know that. That
Yes.
has been skipped. I have skipped it intentionally, in fact. Okay. But if this is understood, then it will be easier for me to make you explain the next day that what is the reason that I'm selecting this particular target SRS. Because as I said at the studying, that there may be a lot of options in your Windows. There may be a lot of options. Okay. In any apps, it's important that I select. It's important to know why I'm selecting it. It's equivalently important to know why I'm discarding the others. So I'll be explaining you this thing the next day.
Okay, sir.
Okay, then make a click on OK and go to start georeferencing toolbar. And if you click on this start georeferencing toolbar, your georeferencing will be started. And it will again show you in the map, as I have already mentioned.
Excuse me, sir.
Ex-
Excuse me, sir.
Do you have any questions regarding this?
Yes, sir. I have.
Actually, the GCP table is not visible in my window. I don't know if there's some issue. Why is it
GCP
not
table.
appearing? The GCP table.
Yeah.
GCP table, if it's not appearing, am I audible? Okay. Just go to view. And go to panels. Panels. View and then panels. View. Not settings. Go to view. To view.
GCP table, actually. This one.
Go to view and then panels and you will get it.
Okay, sir.
Okay, thank you, ma'am.
Thank
I think it's
Sir,
okay for today.
Sir, I have a question.
Yes, please, ma'am.
Sir, after completing the transformation settings, then when we start georeferencing, there is something in the red line called transformation field could not create destination file.
Oh, you have to when you are going in the transformation setting, now you have to give any pathway for that destination file. I mean, say take it very normal. Say you are saving any data in the Excel or Word. So you have to define the pathway and you have to also give a name of a file. Simple as that.
Then in output setting, output file, it was there in where I want to save.
Yeah, actually, you have to provide a proper pathway for that.
So it is coming by default.
You give it on your own. Don't take the default.
Sir, another question, sir.
Yes, please.
Sir, we have the configure georeferencer settings. It is showing point if show ID, show coordinates like that. And it is showing residual units like pixels. Use map units if possible.
Residual units?
it has two options like pixels and use map units if possible.
In the panels, I mean over
Means
here.
georeferencer settings, sir.
Georeference settings, okay.
Settings, yes.
Please click. Configuration
Configure,
georeference. Configure georeference.
configure, sir. Here residual units, it's showing pixels and use map units.
No, whatever. See, if the map units, since we are doing it in a raster, okay. So whenever you are giving these values and this difference of latitudes and longitudes, this is the graphical user interface. That is the software itself. That is the interface as a graphical units. Okay.
Okay, sir.
So if you assign any value to that particular pixel, say for example, you assign a value of 1 millimeter.
Okay.
And your residual pixel is 2.
Yeah.
So it will appear as 2 millimeter.
Okay.
And if you assign a value of say 3 millimeter for each pixel,
okay,
and your residual error is 2, so it will appear as 6 millimeters.
Okay.
Okay. So whenever the fundamental thing is that whenever we are assigning these latitudes and longitudes, since it is a graphical user interface, so it is taking the values in between. That is, what is the distance in between the latitudes or the longitudes, and what is the difference in between the graphical distance. So it's calculating that, and we will be getting a scale straight away over here.
Okay. Thank you, sir.
Moving to that part, we'll be moving to that for the next step, perhaps.
Thank you, sir.
One thing I'll like to request you, I have to close my office. It's already 9 o'clock. The map is already with you. Please come back the day after tomorrow with this georeferenced. Okay.
So can I ask one last question?
Sure, sir.
So this GCP table, you have a residual column.
Yeah, right.
To reduce the residual while georeferencing, do we need to zoom in more so that we...
Two things you can do, sir. I can tell you. You can zoom in more so that you can zoom in the pixel level. See, when you are zooming in, you cannot see these values of latitudes and longitudes. Just take a paper, just take a plain piece of paper, just draw a layout of that, write down the values of the latitudes and longitudes, zoom in high, and then do it. This is one option. And again, to reduce these residuals, a simple statistics says that more number of data you take, the more is your number of sample, less is the standard deduction.
So if we add 2 more,
you can add on points. So the value might reduce. If you add it correctly, the value might reduce.
Right. Okay. Thank you.
Thank you. So let's call it a day for today. I hope.
Thank you, sir. Thank you so much. We will meet again day after tomorrow. Participants, I have already previously done offline class with sir. I can assure you will get all your questions answered in the next session, and just revise what sir has told today. If there will be any questions, sir will surely answer in the next session, and you will get all the answers. Believe me, I have done classes of sir. You will get everything very easy. Everything will be easy to you. So go and revise these things. With sir permission, I want to add one line what sir told us in our last class, that here is a picture and we are making it as a map. So keep in mind that line, because it was very much helpful to us to help us understand the whole situation. It was a picture and we are adding georeferencing, and then we are adding reprojection. We will be adding reprojection to make it a map. We are just making a PDF into a map. Then we will put the data. So with this note, with sir permissions, we are calling it a day. Thank you, everyone. And one thing I want to, sir, one thing I want to, with sir's permission, I want to confirm, sir, should we start the session from 7 p.m. every day? Then we'll get somewhat a bit more time for interactions. So 7 p.m. is okay, because previously we thought it as 7:30. So
no, 7 is okay for me. I was waiting. I joined at 6:58 today. I was waiting.
Okay,
I thought that some more will be joining. Afterwards I saw that you made a WhatsApp to me, but I didn't notice at that particular time. I joined at 6:58.
So it's a request to all the participants. Please note the timing will be from 7 p.m. so that we'll get more time for the interaction. So with this information, please note that from the next session we'll start at 7 p.m. and with sir permission, we end today. We'll meet again 7 p.m. day after tomorrow. Thank you all. Keep practicing. We'll meet again and we'll answer all the questions. Thank you.
Thank you, Anubhav. Thank you.